Quantum fields sound like science fiction. Invisible waves stretching across space, vibrating, even in absolute darkness. It sounds too abstract, too mystical. But what if I told you? These fields aren't just real. They're the foundation of your reality. They're the engine behind your atoms. And they're the invisible force driving the biggest breakthroughs in science today. Google just claimed a quantum leap with its new processor. And this year's Nobel Prize in Physics? It was awarded for proving that quantum weirdness doesn't stop at atoms. It can stretch into the macroscopic world, into the world we can actually see. But here's the twist. None of that makes sense. Until you understand quantum fields. Let's decode the invisible. In October 2025, Google's latest quantum processor, Willow, did something wild. It solved a problem that would have taken even the most powerful classical supercomputer centuries. It's not just fast. It's not just efficient. It's proof that quantum computing is real, and that we're entering a new era of physics-powered machines. But what most people missed was this. Quantum computing isn't about tiny particles doing tricks. It's about tapping into something much deeper, a hidden, humming layer of the universe that makes particles possible in the first place. That layer is made of fields. Just days after Google's announcement, the Nobel Committee dropped another bombshell. The 2025 Nobel Prize in Physics was awarded to Mika Sillanpää, Miles Blencow, and Konrad Leinert for bringing quantum effects into the world of the big. They built systems where not just electrons, but mechanical objects large enough to see were placed into quantum superpositions, two places at once, two vibrations at once, like Schrödinger's cat, but real and engineered in a lab. Quantum physics, once limited to the strange world of subatomic particles, is now something we can sculpt, observe, and even control at human scale. But again, what are we really controlling? For over a century, we believed the universe was made of particles, tiny, solid dots bouncing around like microscopic billiard balls. But as experiments got more precise, reality got more slippery. Particles weren't acting like particles. They were showing wave-like behavior. They could interfere with themselves. They could teleport information. So, physicists flipped the model. Instead of particles being fundamental, they proposed something else. That the universe is made of fields, and what we think of as particles are just ripples. Temporary excitations, local vibrations in those fields. Imagine the universe as an ocean that stretches forever, with no shore, no surface, no bottom. Just vast, invisible waves. That's what a quantum field is. And there isn't just one. There's a separate field for every fundamental particle. An electron field, a quark field, a Higgs field, and where those fields overlap, interact, and ripple, we get what we call reality. An electron isn't a thing. It's a splash in the electron field. A photon? A twitch in the electromagnetic field. A qubit, the heart of a quantum computer, is a delicate, controlled vibration in multiple fields at once. Even if you vacuum space completely, cool it down, remove all particles, the fields don't vanish. They jitter, they buzz. Virtual particles pop in and out of existence constantly. The vacuum is not empty, it's alive. This is what Google's chip and the Nobel experiments work with. They're not manipulating particles, they're shaping the fields underneath. That's why quantum machines operate near absolute zero. To calm the storm and let the smallest ripple carry a message. And if we master field interactions, we're not just building faster computers, we're tapping into nature's code. But the question still haunts us. What are the fields themselves made of? We don't know. Quantum field theory tells us how they behave, not what they are. Maybe the fields are made of information. Or maybe they're just the skin of something deeper, entanglement, geometry, or something we haven't imagined. But what we do know is this. You are not made of particles. You are made of patterns, of organized ripples in overlapping fields. You are the universe, a ripple in its own song. If that just rewired your brain, subscribe to Explainasphere. And if you're still curious about how something can exist in two states at once, check out our video on Schrödinger's cat. It might just make you question what's real, all over again. And tell me in the comments, if reality is made of waves, what kind of music do you think the universe is playing?